Right, so what I'm showing here is IO-Link technology. So as you saw in the presentation about how we can interface to smart sensors from your existing factory network. And basically if I go to start here, I'll just take you through the devices that we've got hooked up. So the network side of it, basically we've got a Profinet IO-Link master there. So what that is, it's a Profinet node. It sits on the Siemens Profinet network, but it's also an IO-Link master, which means it can control the communication from this network. This is the green network cable going in here to the smart devices here. So these are all IO-Link devices hooked into it. So let's start off with a power supply. So what we've got here is an IO-Link power supply, and what that means is we can send more data from the power supply about its status, and we're doing that via this cable here. So that cable's plugged into the IO-Link master, but what we're showing on this HMI here is that we've got extra data about its status, such as whether it's over voltage, whether the current status is okay, if it's over temperature. So if you had a problem such as your fan went down in your panel to cool it, you would know from the power supply status how it's doing. Okay, this one here, this is basically shows how we can control the standards. In this case, it's a Festo valve islands. This connector here, it's basically an IO-Link valve connector, and what that does, you'll see there's lots of pins in there, and that's typically the connection you'd have on your standard valve island. So normally you'd have about probably 25, 27 wires coming out of that. You'd have to take those all the way back to the control panel and wire them up individually. What this does is it basically converts it to IO-Link. So it converts all those signals down to 4 wires inside that cable, and then that is connected in the field into that module. Because these modules are all rated at IP68, so they're all field mounted. And you can see that then we can actuate output signals represented by these LEDs. And all that data is just literally going back through this cable here, back to the controller, and you've just got a power cable there. So it massively reduces wiring. Okay, here we've got an ultrasonic sensor, so that's just sensing my hands. We've also got it hooked into this light unit here, which is what we call a smart light. So this is basically an intelligent stack light, and the reason it's intelligent is because it's got 3 modes on it. So rather than just having just simple segments like this, it's actually got a level mode on it. And it's also got a run light mode, which you probably won't see because I'm doing stuff with it, but that just indicates the running condition. And the great thing here is that with the ultrasonic sensor, it's sending back measurement data as well as the switch point data. So we're getting much more information back from it straight through the bus system. And you can see on there that we've got a switch point as well as this measurement data goes straight back to the controller. Linear transducer, that's a similar sort of principle. It's a measurement device, it's communicating on IO-Link. Typically in the scope of an Industry 4 solution, you might use that on something like a press to indicate shut height. So if you put a different die in the press, basically you can determine what the shut height of the press is because you've got feedback signal. And this, so I'll show you this using this one actually. So we can send power and signals across an air gap. So if you've got removable tooling, typically on a robot, if you see that there's no wires. If I put it there, and you've got power and signals traveling across an air gap. So we can send up to 800 milliamps at about 2 mil range. Basically you'll see on here, we can actuate outputs. You'll see them appearing on here and changing. But we can also receive signals back. So if you look at that LED there, you'll see that that comes on when I trigger it with my finger. So that, as this shows on here, what that can be used for is format changes on machines where you've got a different part to handle. You might take that piece of tooling off, the robot drops that down, and then basically you can pick up another piece. And that piece of tooling does a different job, but uses the same standard connectors to transmit the power and the signals. So that's a great sort of example of an Industry 4 application. And then we've got, okay, I'm done now then. Thanks a lot. Brilliant, thank you.